Alright. You have done multiplication for many, many years, yes? Okay. Well, but what is multiplication? Tell me what is multiplication. Yes, sir.
Multiplication is it's the same thing like addition, but you times the number
Okay.
is
Okay. It's addition and what do you mean? You're timesing by the number you're multiplying by. I'm not sure what you mean by that. Can you be more specific? Does anybody else have a way that they'd like to say that? Yes, sir.
Multiplication is like addition because the number that you're multiplying is like 5. You have to put the number on top of it like 5 times.
Okay, so you would add that number 5 times. You have that same number, however many times you're multiplying by it. Yes.
Or it's kind of like doubling up numbers, but it's kind of like addition, but like whatever you have, you don't add it. You have to what she told me that she said you have to practicing this.
Yes, ma'am.
Whenever like on a multiplication chart, if you're dividing up like if you're you're doing 3 times like something, you're gonna keep on going down, and then you can have 3, but we can have a different number.
Okay. What happens to my number whenever I multiply it by whole numbers? Does it get bigger or smaller?
bigger.
Okay, if I'm multiplying by whole numbers, it gets bigger. We've said that it's kind of like adding. Can I say that it's repeated addition because I have the same number I'm adding every time?
Yes.
Okay. Can I tell you how many groups and how many in each group?
Yes.
Would that be the same as multiplication? Yes, no?
Yes.
Okay. All right. You've done things like, right? You know that. What is 4 times 5?
20.
Okay, moving on. Now, what if, can you use a picture
Yes.
to show me the answer to 4 times 5? What do I call it whenever I fill in this missing part here? A what?
Array.
An array.
People are right now.
Yep. I am.
Why not perimeter?
Would the perimeter tell me? No, if I use perimeter, it wouldn't tell me the inside part, because that's what I care about here is the inside. We'll get there. We're not too perimeter yet this year, but for right now, if I'm looking at the inside of this array, do I count these ones on the outside? Do I count how many are on the outside or just what's on the inside? Inside. I can count them by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can count them by ones. Can I count them by 4s? 4, 8, 12, 16, 20. Can I count them by 5 this way? 5, 10, 15, 20. Okay? So no matter what, here on the inside, I have 20. And that tells me my answer to 4 times 5 equals 20. Okay? You with me?
Yeah.
Okay. Please stop. Okay. Edit. I'm about to erase all of it. going to put 14. 1, 2, 3, 4. Do you agree that's 14?
Yeah. Yeah.
Times 23.
Yes, that's perfect.
Okay. Now, if I have a 10 across the top and a 10 down, what does that equal?
100.
I'm gonna ask that question again. If I have a 10 across the top and a 10 down, whenever I multiply.
20.
What is 10 times 10?
100.
Oh my goodness.
She said 10 plus 10 is 20.
10 plus 10 is 20, but if I'm talking about an array, am I talking about adding?
No.
No. Okay, fantastic. What about, again, I have 10 across the top and 10 down the side. What do I have? Another 100.
Why are you adding 100?
Because I'm filling in this array.
What she's doing is trying to get her answer.
If I take and put these here, I'm filling in these parts. I'm filling in the missing parts here.
There's an easier.
But right now, this is what I'm doing. Are you with me for why I have 200s here? Okay. Now, here on this next part, I'm going to put how many across the top? 4. And how many down? Times how many down the side here?
7.
4 times 10.
Equals 40.
There's 40. But I have another 10 down here.
That's 80.
Okay. So this would be 80. Alright, now I'm going to do this along the bottom down here. 1, 2. How many right here across the top? 10.
10.
By
3.
3. Okay. It's 30. So look, I have 10, 20, 30. Now I'm going to fill in my missing pieces here.
It's 42.
3. All right. So here I have filled in my array now. Yes. Okay.
On a
Now it was kind of time consuming, and that's okay. But I actually want to show you something.
A crossroad?
Do you see how I can take and kind of separate
Yes.
my parts?
Yes.
Okay. Just want to point that out. In this first part right here,
200.
we got 200, but really, how many did I multiply that by? 10 times how many down the side? Times 2? 20. And what did we get?
200.
What?
200.
Yeah,
I can't do the math.
Okay. Now,
You're actually doing
what if I come off to this next part? How many were along the top?
4.
Times how many down the side?
4.
Times how many down the side? 20, because I'm just talking about this part. So how many do I have? 10, 20, 30, 40, 50, 60, 70, 80. 80. Okay? What about this next bit down here? How many along the top? 10 times how many down the side?
3.
Which gave me how much?
30. Is that your answer?
Okay.
283.
Hold on. What about this one? What was along the top?
4.
4 times what was down the side?
3.
4 times 3 equals
12.
12. Could I count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But still got 12. Now, these are called my partial products. They're part of my product. Is the whole answer?
No.
No, it's just part of my answer. So here, what do you think I need to do with 280, 30, and 12? What do you think? Yes, sir. Add them up. 280, 30, 12. 2, 3, 12, 322. Okay. Guess what? That is the answer. 322. Now, was that very efficient? Is it very efficient for me to take out my base 10 blocks and be working and putting out my base 10 blocks? Okay? I'm going to show you something that's very similar to this, but you don't have to get out your base 10 blocks. You ready?
Are you plus 1?
You can use
Is it part from? I don't know what you're doing.
Okay. This I use pictures. Okay. This I call the array model. Or area model. Either one.
Area models.
Okay? So what I do for the area model is I break it up just like I did here. I'm going to take 14 and I'm going to break it into 10 plus 4. Does 10 plus 4 equal 14?
Yeah.
Okay? What did I do to 14 when I wrote it as 10 plus 4? I did what? I made it be expanded form. What about if I need to break up 23? How am I going to write that in expanded form? 20 plus 3. All right. So, in this first box, what number is on the top?
10.
10 times how many down the side? 20. Now, this is your zeros trick. Some people told me this morning that they've already done it, but they didn't put things in triangles. I'm going to encourage you to put them in triangles. Okay? There, 10 times 20, I have 2 zeros at the end of my numbers. So I'm going to take them and shift them to the other side. And then what's 1 times 2? So guess what? 10 times 20 is 200. Okay? In this next box, what do I multiply? 4 times 20. 1, 0. What's 4 times 2?
8.
8. This next box, what number's on top? Times what number's down the side? What's 10 times 3?
30.
What number is on top of my last box?
4.
4 times
3.
what's on the side?
3.
3. 4 times 3 is
12.
What do I need to do with 280, 30, and 12?
Add all the numbers to get the total.
Add them up. What did I call those numbers?
It's not too hard. It's not hard.
Nope.
Part.
You now have 2 ways to solve a 2-digit multiplication problem. You've got your pictures in your area or array model. Okay? Very similar, aren't they? This one just has pictures, where we kind of took the picture part away, but we did all the same parts. Look, that's the same. Hey, look, that's the same. Hey, look, that's the same. Hey, look, that's the same too. Okay? So instead of drawing the pictures here, or having out my base 10 blocks, I just used the numbers there. Okay? Does that make sense? Yes, yes, sir. Okay. You with me so far? All right. So if I gave you one of these, you'd be able to do it.
Yes.
I can do that.
No, for real, I can do that. It's just right.